Okay, so in the chapter of work energy power, further we have to discuss the concept related to the power. And if you remember that, what is the definition for power?
Power is work. Power is work done over time, so it's the rate of work done.
Yes. So simply it is known as the rate of doing work, which is known as the power. So basically rate of doing work is known as power. You already know this concept, and simply we can write the formula as equals to W over T, or we can also write over T. E is for energy because we know that both are having same units. So sometimes they just give you the value of energy. And by SI unit, we use the same definition for energy also. The equation for power, and the SI unit for power is,
There's a few different equations for power, right? There's also like power equals to VI or
yes,
power equals to I
yes.
square R.
But if we are talking about the electrical quantities, so then we have to use P is equals to VI, P is equals to I square R. So that is for electrical section only. But if they are asking the concept of power in dynamics, kinematics, so never use that formula of electricity in this section, and never try to use this formula in that section of electricity. In
You
electricity,
won't have the
yes, but in
you won't
electricity,
have
you remember, we derive from the basic concept, right? Okay, so we
right.
derive the formula from this concept. So this is the base concept, but we are not going to apply that formula because that is the derived concept for electricity. And this is the base concept.
Okay,
So this is the only
got it.
difference. So you can easily identify because the questions are completely different. So it will never mix the concept.
Okay.
So watts is the SI unit for power, and 1 watt is equals to 1 joule per second. So that is the concept of power. And you already know about the concept of the formula related to the power and the numericals that we have to solve, because in IGCSE we also solve lot of problems related to energy, power, work done. And there is
Yeah.
also a concept of efficiency, right?
Oh yeah, it's easy.
Efficiency.
It's power in divided by power out divided by power in times 100.
Yes. So
Or like energy used by energy in.
yes. So power or energy output divided by power or energy input, or the total power or energy, we can say that. And there are different concepts like useful energy divided by the total energy, or useful power divided by the total power. So basically concept is very simple, just like calculating the percentage of our exam or of our test. So same is for the efficiency, right? And further, if we talk about the power, so now we have another concept for the power, which is known as the product of force and velocity is also known as the power, right? How? So let's suppose if they ask you to drive or prove that. So you have to prove that the product of force and velocity is also known as power. So how to drive this concept? Let's suppose if we take the basic definition of the power, which is known as P is equals to W upon T, and we know the basic formula that W is equals to F into D. And if we just combine the two quantities, distance over time, so you will get the value of velocity from distance over time, right?
Right.
So you can see this is another formula that we can use in our calculation that is related with the force, velocity, and power, right?
Mm-hmm. Because power is work over time and work is FD. So distance over time is speed. So force multiplied by velocity is gonna be your answer.
Yes. So basically, this is the concept of a new concept for the power, or you can also like in MCQs if they ask that power can also be defined as, so you know that the product of force and velocity, or like if they ask about with the reference of SI unit, so you may also write like Newton meter per second is also known as the power. So now if you got the basic formula, so you can easily write the SI unit. So that is not much very difficult task, right?
Right.
And further, if we talk about the law of conservation, so we already discussed that if we are talking about energy, so energy can be transferred from one form to another. That is known as law of conservation of energy. And secondly, if we talk about the derivation of kinetic energy formula, just like we drive for the power. So if they ask about the derivation of, so basically kinetic energy is equals to half mv square, and we know that this energy is due to the motion of a body, right? So we already know that. So now we have to drive this formula that how we got this formula, what is the basic concept and what is the derivation behind it. So let's suppose if we start the derivation. So first of all, if we consider one body, mass of the body is equals to m, and let's suppose if we consider some distance, so ball or this body has to cover some distance with some speed, right? So basically initially the ball is at rest, and when it starts to accelerate with a speed of v over a distance t, so you know that work is actually done over here. So we take start from the concept of work done, right? So work done is equals to F into D, first equation. Secondly, we know that force is equals to mass into acceleration, right? Uh, and secondly, if we just substitute this value in equation one, so W will be equals to ma into D, okay?
Okay.
And further, if you remember that equation of motion, remember that we derive some equation for motion.
Yeah. The v square equals u square plus no, it's v square equals
So let's
u
suppose
square.
yes, if we start from rest, so initial velocity will be equals to zero, right? So we have to use the equation like the final equation, final velocity, initial velocity with distance also, right? So we have to use the equation. Okay, so this is the equation that we drive. And if we use this equation in this scenario, so we know that initial velocity is equals to 0. So your final speed will be equals to 2AD, because we just take distance as d or s, it is not a big deal.
Okay. So energy is like, it's a scalar quantity, it's not a vector quantity.
And further, if you talk about the value of a, if we take the value of a from this equation,
Which is gonna be V, it's gonna be V minus U
no,
of
we
V squared.
have to divide 2d on the other side, so it will be equals to v square over 2d, right?
Oh, yeah.
So basically, we got the value of a, and we already got the value of f. And if we
Wait,
substitute,
what did you do with U square?
basically initial velocity is equals to 0.
Okay. So it's gonna be 0 squared, so we're gonna remove it from the equation.
Initial velocity is 0, so that's why that will be also equals to 0. And now let's
Okay.
suppose we substitute this equation in equation number 2. So if we substitute equation number 2 in equation number 3 into equation number 2, so equation 2 will become f equals to m into v square over 2d, right? And if we just open up the bracket, mv square over 2d, right? And finally,
Yes.
we got the value of f, and just finally we need to substitute this equation back in equation number 1. So you will got your final result.
So equation number 2 is F equals to mass multiplied by acceleration. So what we're gonna do is F equals to mass multiplied by V squared divided by 2D.
So basically we
So then,
just substitute equation 4 in 1. So in equation 1,
Mhm.
w is equals to ft. So you just simply place the value of f in w equals to ft formula. So
Right. Also, and then it's gonna, when you're like moving it around, it's gonna give you half
yes,
because there's a 2 stuff. So this is the fourth equation. This F equals mv squared divided by 2d.
yes, that fourth equation that we used in our derivation. And finally you got your final value. If we write constant value first, then the variables. So w is equals to half mv square, and you know that work done or energy makes the same sense since body is moving. So we are doing
So
work,
the
and
d,
d
I
cancel
was
up.
saying, so the, okay. Yeah, that's what I was just confirming.
So basically, the work done in moving the object will be equal to the energy possessed by the body during the motion. So that means, so this is the proof of the equation, right?
Right, got it. There, it's like a bit complex compared to the other derivations.
Yes, because we have to take assumptions
Four
from
different.
equations. So it is slightly different from the other, because in others, we are just taking reference from one and we are just moving towards the rest of the part. And in your A2, you will also find derivation like a tricky one as compared to this one, because these things we already discussed. But in that, you have to know about new formula and also their derivation. So that will be more interesting than this one, because in this we just got the concept that how to drive equations, how to know about the basic concept that how and why they use this equation or why they drive this formula. So you got the basic knowledge that yes, this is the concept that we are driving from this reference.
Okay.
So this is the derivation for kinetic energy formula.